Alright guys, we're going to get ready to kick things off on the final home stretch of the day. So in the next hour, we're going to talk about two different platforms and tools that have open source roots and have commercial distributions and versions of the software. And so we're going to start off with talking about Ansible, and then in the next 30 minutes we'll talk about Batfish, but I'll just hand it over to Ajay and we'll kick things off.
All right, can you guys hear me? Can you guys hear me? Yes. All right. Thank you. All right, so this session, we're going to look at how to run Ansible at scale, how to improve performance of your Ansible playbooks, what are some common strategies, what are some common things that you can do to improve the way you use Ansible. Alright, so before we get started, let me make sure I have my timer. So this is going to be 30 minutes, right? So 30 minutes we're going to try and cover this topic. Real quick show of hands, how many of you in the audience today are using Ansible for network automation? Awesome, great. How many of you have run into scaling problems with running Ansible for automation? All right, so the rest of you are good. All right, so let's talk. Let's look at some things that we can use to improve Ansible. Right. So, quick introduction. My name is Ajay Chenampara. I work for RedHat, trying to help the public sector, the North American public sector, right, with their adoption of Ansible. On the right-hand side, you can see some ways to get in touch with me. So I'm going to first talk about a typical usage pattern that we observe, how people get started using Ansible and what problems it leads to and how that can be solved, and then eventually how we will scale that problem, how we will scale that solution. Okay. So typically the use of Ansible begins with an engineer or a group of engineers using Ansible to solve a given problem. Okay. They write a playbook, they solve a problem, and soon their teammates realize that, hey, I can use this too, right? And they start sharing their playbooks. And that team starts using Ansible to effectively make their lives easier. And this same pattern can be observed across different teams, not just the compute side, the storage and cloud side, the network team, right? So now you have entire teams, using their laptops, sharing playbooks, and trying to build these automations and others. Now, that can lead to some problems, right? And I like to think of these as problems of scale as well, right? So problems like, why does my playbook work on my laptop but not on his or her laptop? Those kind of questions, right? Because one person might be running a different version of Ansible from the other. There might be some underlying dependency problems, right? So even though you're running the same version of Ansible, they might be using a different dependency library that Ansible uses. There might be a different version of GT2, for instance. And then there are problems from an organizational standpoint as well, right? From an organizational standpoint, right? How are we keeping track of who is doing what, right? What organization has what permissions to touch what inventory? How are we keeping track of the credentials, right? So these are some challenges that come into play. Then there's compliance, right? You want to have an audit history of what changed in the environment. Finally, I'd like to also point out about integrations, right? Morning you saw a great demonstration of using integrations, right? Using ServiceNow, using the Google Voice thing, right? Fantastic demo. But those things are soon becoming reality, right? Those things are becoming automation requirements for organizations. How do you handle those? Okay. While you can potentially build something in-house and solve it, right? All these things come pre-solved. Those are the use cases where you want to address something like Tower. All right. So from a standpoint of where I'm going with this, right? So we started with individual engineers writing playbooks, right? that becomes a team thing, that becomes a team of team thing. Now recognizing the problem, all these are being consolidated into one, let's say, form factor or one entity, right? Let's say we're using tower for this. Now this tower needs to be scaled. Now you're running so many playbooks. Now you've consolidated so many playbooks into being run from this entity. So how do we make sure that tower can be scaled appropriately to handle all these different workloads? First thing you want to think about while trying to, with respect to this particular audience, right? Since our focus is going to be network automation, I want to take a quick minute to, I guess, set the base about how Ansible works, right? So on the bottom of this slide here, you can see how Ansible works for compute systems, right? So on compute systems, the computation is distributed. What I mean by that is when Ansible runs on a control node and the automation is pushed to these endpoints, the actual automation effort or the computation behind the automation happens on the endpoints, right? So the SSH connection is established to Linux or Windows machines. The modules are pushed to these endpoints, and then the modules are executed locally on those machines, right? Which means the compute happens on the automated endpoints. For network devices, as we all know, right, we're dealing mostly with closed systems, we're dealing with proprietary systems, we're not able to push these modules to these devices and execute them locally there. So Ansible is forced to execute those jobs locally. Right? So Ansible establishes a connection to itself, runs the modules locally, and then while those modules execute, commands are generated which are then pushed to the devices. Which means there is a little bit more significant computational requirement required on network control nodes. Okay, keep this in the back of your mind throughout the rest of these slides, because everything that I'm going to talk to beyond the slide depends on this particular base understanding. Okay. So first thing we want to do is we want to see how big a box do we need to handle all the automation that we want, right? So as a rule of thumb, Ansible specifies that you need to have at least 100 MB of memory per fork, and every CPU can run up to 4 forks. So what's a fork, right? Fork is nothing but a Python process, right? As far as Ansible is concerned, it's nothing but a Python process running against one host in the inventory. Okay. Now, there are some other considerations you need to keep in mind when you use when you're factoring the size of your host. There are things that are reserved. For example, if you're using Ansible Tower and you're trying to do an inventory sync from remote databases, that's going to take up 1 fork. Okay, so there are other internal things that if you're doing a project sync, same thing, it takes up 1 fork, right? So when you're sizing a box, let's say it has X number of CPUs and so much of RAM, Ansible gives you a formula to calculate how many forks can run on this particular box, right? So, from a memory standpoint, the way this is calculated is take the total memory, subtract 2 gigs, right? 2 gigs is reserved for Tower's jobs, and then you divide it by the memory required for 1 fork, which is 100 MB. Okay. Similarly for CPUs, right? So if you have X number of CPUs, you know that 4 forks can run on 1 CPU. So it's a simple multiplication there, right? And as an example, if it's a 4 gig memory, 4 CPU system, right? If you're trying to calculate from a CPU boundary, you can run 16 threads. But if you're thinking of it from a memory standpoint, you can run up to 20 threads, right? So the main point I want you to take away from this is, forget about all the math, right? So the idea is that depending on the type of devices you're automating, the number of threads you can run to size that box is going to depend on the endpoint, right? So if the endpoint requires you to do local execution, you need a more CPU intensive system compared to if you're able to distribute the computation out and you're able to pretty much fan out that computational process. Okay, so just keep that in mind, and you'll always find this slide, or you'll find resources online to figure out how to scale your box. The formula is right there on the website. And if you're using Tower, Tower has the inbuilt algorithm that calculates all this stuff. So it's pretty much a slider you go into, and you can see hopefully a screenshot there. There's a slider there that you can slide to size how many forks you want to run on this particular machine. Okay, so that's the first thing you do, is try and figure out how big a box you need. Okay, now bigger does not always means better. Okay, and we'll talk about that when we look at some of the clustering considerations with Tower. What are some of the other scaling considerations you want to think about when you are trying to scale out your Ansible playbook? Right. One is the size of the running config on the devices. The reason for that is many of the modules in Ansible are going to be idempotent. What that means is every time you're going to push a change, it's going to try and compare against the running config of the device. So if it has a large running config, it's going to take that much longer. Right? Another consideration is if you have devices that are slow to respond, are already pegged from a CPU or memory standpoint, those might respond slower than the others. Right? Then there are differences between what type of platform you're trying to automate. Right? So our consultants have experienced that with an iOS device, usually the performance is 4 times faster than with NXOS devices. Frequency, right? How often are you doing this thing? And then finally, the usage or availability of network facts. Now, this is we'll go a little bit into how to deal with facts, but having the ability to, if your network supports, facts like iOS facts, EOS facts, Junos facts, all these facts modules that come from Ansible, that's going to make your performance a lot better when you have to deal with parsing operational data or configuration data. Okay, at the same point, if you're working with a device like an ASA device, right, and there's no ASA facts module, right? So how do so that's another scaling consideration, right? Devices that have facts modules versus do not have facts modules play into some of these scaling considerations as well. Okay, so far what we've looked at is we've seen the how Ansible grows in an organization. We looked at how Ansible automation differs for network devices versus compute devices. Right? We looked at some of the automation considerations, and we looked at a quick formula as to how to size your blocks that you want. Now let's look at some common strategies that you can use, without too much difficulty to get your automation playbooks to perform a little better. Right? The easiest one is caching facts. Right? It's as easy as clicking on a checkbox saying use fast cache. Right? So you fact cache. Right? So you enable the checkbox, and what that's going to do is it's going to cache all the facts for that particular device, right? So if you're storing your variables, right, host vars, group vars, any of your metadata that you're using for your automation, all that information can be cached and available for subsequent playbooks. Okay. Now keep in mind that you don't have to run these facts or facts gathering for every single playbook that you write. You can you can divide and conquer, right? So you write a specific playbook that just goes and gathers all the facts, maybe schedule it on a nightly basis or something like that, right? Goes and collects the facts and keeps the facts in the facts database so that these facts become available for any playbook within that inventory. Okay, so One point I wanted to make is that, I referred to Ansible Tower, right? So these same things are applicable to AWX, right? One-to-one. All these features are available and usable in AWX as well, right? So this is the easiest thing you can do, right? From improving your playbook performance, enable fact caching. Okay, and if you're using Tower, by default, it's going to use memcached as its caching mechanism. You have options like storing the cache information into Redis or Redis, right? How you pronounce it. And then you can store it into the memory locally on the machine. So when you're trying out, when you're starting off, you have multiple options to play around with. If you're using Tower or AWX, it's going to use memcache to store it. Alright, some other common practices that you can do, right? So from a scaling standpoint, right, you can also scale a little bit of the effort you would take to build these playbooks. So when you write your playbooks, try to think of them as reusable functions, right? Write them as roles. Make sure that these roles are made independent of your playbook itself. Right? Store your roles in separate repos compared to your playbook repos. Store the metadata in group vars, host vars, right? Use smaller inventories, leverage limits and tags, right? So these are probably common things that as users of Ansible you're already familiar with or already using, right? But these are some best practices that will help improve your playbook's execution as well. Okay. Now there are also certain plugins that you can tune depending on your use case, right? And I say depending on your use case because it is fairly subjective. If Ken was here, I would have pointed at him saying that it depends, right? So it depends on your use case as to how you want to use some of these plugins. For instance, by default, right? So Ansible supports 3 strategy plugins, and I'll go over this real quick. The default plugin is the linear plugin, right? What the linear plugin does is, let's say you have 10 tasks in your playbook and you have 100 hosts in your inventory. It's going to execute task 1 for all the 100 devices, then go to task 2, all the 100 devices, and so on. Right? So that's going to make it perform in a different way compared to, let's say, the free or the host pick. Right? So the free strategy, what that does is, as soon as a host completes task 1, it moves on to the next task. Okay, and the host pin strategy, what it does is it completes all the tasks for host 1, then it does all the tasks for host 2, and so on. Again, depending on how many forks you've set for that particular strategy. Okay, by default, Ansible spins up 5 hooks. Okay. So it's going to do it 5 hosts at a time. Also be aware of the connection plugins, right? Depending on which version of Ansible you're using, if you're still using an older version of Ansible, you might be using local connection methods. You want to move away from using local connection methods to start using things like network CLI. Right? What network CLI is going to do is it's going to ensure that SSH connectivity to the endpoints are going to be persistent. Right? So it's not going to establish a new SSH connection per task. So you get some efficiency for each task execution. Cool. Okay, so we have looked at how to scale Ansible vertically. We've looked at some common things that you can do to improve the performance of Ansible. Okay, so now let's see how to scale Ansible Tower horizontally, right? So what I refer to here is clustering. So when you get to a point where vertical scaling is not going to help you and doing all these common practices are still not good enough, you still have a huge inventory against which you want to automate, that's when you want to think about, okay, now we got to, how do we scale this out? Okay. So here's a high-level architecture drawing of a scaled out environment. Right? And we'll go through some of these components and scenarios and terms in the following slides. But clustering in Ansible Tower was introduced in Tower 3.1. Okay, in 3.1, but there was no control over how to allocate a particular job to a particular clustered instance. You could not also do things like partition out your cluster depending on organization or teams within, the Tower RBAC ecosystem. Is there a question? You just stretch it. Cool. Okay, let's understand some nuances with clustering, right? So cluster in Ansible Tower 3.2, two concepts were introduced. One was instance groups, and the other was isolated nodes. So let's talk about this for a second. So what are instance groups? Instance groups allow you to dedicate a cluster for a particular purpose. Okay. So remember how I talked about, the execution for network devices is local versus remote, right? So if you have multiple organizations within your Tower configuration, if you have a team for compute, if you have a team for network, if you have a team for storage, if you have a team for DevOps, whatever, right? If you have a team for DevOps, you want to be able to allocate or dedicate certain clustered instances for those particular teams, right? So you can also use shared resources, right? So here's an example of how that looks like, right? So if I point over there, I guess I can move and point, so I'll just use my mouse. So you can see, or here, you can see an instance group called Tower, right? So you have 3 Tower instances, and then you have, that's common, right? You have a common instance of Tower nodes. Then you have an instance group that is dedicated for the network team, right? And within that, you can see that there are 3 nodes, right? Net 1, Net 2, and Net 3 that have been dedicated to the network team, right? Let's assume these are CPU, high CPU devices. And then you can also add, additional resources. So when jobs, when you write a job template, and you can tell the job template, right, which instance group to run this particular job template in. So for the network team, you can tell it to work with just the network instance group. Similarly for the compute team, for the prod team, right? So you're able to allocate and distribute your job template. So Tower simply becomes a control plane or management plane, right? So you're managing how your jobs are run, and you're able to kind of distribute where exactly these jobs are run. Okay, so allowing you to scale as much as you want. Isolated nodes extend this idea a little bit more, right? What isolated nodes allow you to do is they allow you to provide, headless Tower boxes, right? So you have that central control plane or management plane that Tower is providing, and then as long as there's an SSH connectivity to these isolated nodes, you can specify certain jobs to be run from those isolated nodes. Right? This can be dedicated based also on an inventory, right? So where that would make sense is, let's say you have a super secure enclave, right? And in that enclave, you can't. There are very specific devices that can manage the devices inside the enclave. As long as Tower has SSH connectivity to a group of devices inside that enclave or a single device inside that enclave, that can become your isolated node of execution for the rest of the enclave. So the use case there is security, right? But it can also be from latency and scale, right? So if you have a central Tower installation in your, let's say, Cincinnati data center, right? But you're managing devices in AWS East Coast and West Coast. Right? So you want your isolated nodes within that VPC, within the West Coast VPC or within the East Coast VPC, so that they're closest to the endpoints that they're automating. Right? So isolated nodes allow that particular function. Okay, so these two ideas of instance groups and isolated nodes were introduced in Tower 3.2, right? So depending on which version of Tower you're running, these features may or may not be available. And again, with AWX, you're going to get the latest and greatest, right? So it's going to be latest and greatest, but it's also going to be whatever the community is providing. Okay, so this slide shows you how to set up an isolated node, right? So these slides, the idea of documenting this in these slides was this becomes a central point of reference even after this session, right? So these slides will be available, so you can kind of have a reference point as to how to configure isolated nodes, right? So the key point here is when you define your isolated groups, you want to tell it which is the controller instance. Okay. The final idea that I'd like to present here is job slicing, right? So job slicing as an idea was introduced in Ansible 3.4, right, which is the current stable release of Ansible. So what job slicing does is that it allows you to take an existing job template and divide how many devices that particular job template is running against. Okay, so remember what I said earlier, right? You can by default Ansible spins up 5 forks when you run a job, right? So it's going to hit 5. If you have an inventory of 100 devices, it's going to run that, but the task against 5 devices, and then the next 5 devices, and so on and so forth. What job slicing does is it'll take that single job and it'll break it down, right? So if you have an inventory of 100 hosts, right? You can specify how many slices that particular job needs to be broken up into, right? So in this example, you can see there are 3 slices, right? So each slice will run against 5 hosts, right? So each of those slices will function as though it was a separate job template. The idea here is that it takes a job template and treats it like a workflow template. But that also implies that the right types of jobs you want to use for job slicing are those where the hosts do not have any interdependencies between the tasks, right? So if it is required that task 1 has to be executed on all hosts before task 2 is executed, right? For network devices, sometimes that's a very typical use case, right? You want to introduce the VLAN on the distribution layer before the access layer, let's say, right? So those kind of jobs are not suitable for job slicing, right? However, things like backing up configuration of devices, where there is no dependence between the hosts, tasks like gathering facts, right? Earlier I told use facts caching and write a meta playbook that goes and collects facts. Like those kind of tasks can be sliced into as many instances as you need, right? And again, you can allocate these to different instance groups, right? So you're able to distribute and scale. So from an Ansible standpoint, right? It's very loud and clear, to the developers that scaling with Ansible is a challenge, right? What these options are providing are, flexibility, right? So, and again, the reason is because, automation is not a turnkey box that you put on somewhere and just turn on a knob, right? It's very, very subjective, right? And in many instances, it's layered where you have to integrate and interact with multiple APIs. You have to maybe query, Netbox, and you have to work with, Slack or chat apps or whatever your scenario is, right? So it's very, very subjective. So each task might have its own dependencies as to the system's performance, right? So what Ansible is providing is all these different flexible options so that you have more than one way to potentially solve it, right? But the key here is to understand what these different things are, what they do, so that you can leverage them accordingly when you run into those situations. Right? And with that, I'm going to end this talk and I'll open it up for questions.
Deploy over your life.
A little louder.
So, which of these techniques do you see deployed most often in real life?
So, the customer base I deal with is the North American public sector. And within that particular space, I personally have not yet encountered, scaling issues. However, the consultants I spoke with, they spoke about scaling about 15,000 network devices for I think it was Microsoft. And in their experience, right, the way they handled it was using multiple different strategies, right? So they built. The first thing they did was they broke down the inventories. They did all the basic stuff, right? All the basic patterns. They made sure that vertical scaling was done right. And then at that time, job slicing was not yet introduced, right? So instance groups were used quite effectively, right? Isolated nodes were not required, right? So the way they solved it was mostly instance nodes and some best practices. Yeah. Has anybody in the audience used Ansible Tower clusters for your network automation? Okay.
All right, great.
Cool. Thank you.
Thanks, Ajay.